For part A of question 1, I will add the two powers. So I have 5 to the power of 19. And then for part B, I will do division. So 800 divided by 2 is 400, divided by 2, 200, again by 2, 100, 2 again, 50, 2, 25, divided by 5 gives me 5, again by 5, and I've got 1. So the product of prime factors is 2 to the power of 5 times 5 to the power of 2. For question 2, I'll create 2 extra columns, one for the midpoint of each group and one for the product of the frequency times the midpoint. That's how they look like. F is the frequency. So the midpoints are 10, 30, 50, 70, 90, and f of x, as I said before, is the product of the frequency times the midpoint. So I've got 50, 330, 400, 1330, and 810. Now note, I need an estimate for the total amount of money. So I need an estimate for sigma fx. Sigma stands for the sum of, and sigma fx is the sum of this column. So 50 plus 330 plus 400 plus 1330 plus 810, and my answer is 2920. In question 3, tin A contains x buttons, tin B contains 4x, and tin C contains x minus 7. And if I add these three numbers, I will have 137. So 6x is equal to 144, x is equal to 24. Note, I'm interested in the number of buttons in tin C. So I have 24 minus 7, which is equal to 17. In question 4, I'll need to find the diagonal, let's call it x. I'll use Pythagoras theorem, so x squared is equal to 8.5 squared plus 5.6 squared, which is equal to 103.61. So x is the square root of this number, and the answer is 10.2 to 1 decimal place. For question 5, recall that speed is equal to distance over time. Now in this problem, the distance is 2470 kilometers, and I need the time in hours. So make a note here. The time is 3 hours 36 minutes. This is equal to 3 and 36 over 60. You can simplify it as 3 and 3 over 5, or even 3.6. So make sure you do not use 3.36, you use 3.6. The answer comes out to be 686 kilometers per hour. For question 6, place the pin of the compass at point A and draw an arc of a circle like this. Now repeat with the pin of the compass at point B, and finally join the 2 points of intersection using a ruler. Note that when you make your arcs, you don't have to make them so big. You cannot make smaller arcs, 2 at the top, 2 at the bottom, like this. In question 7, I will add the two equations and I get 10x, the 5y and the minus 5y cancel out. This is equal to minus 5. So x is minus 5 over 10, which is minus 1 over 2. Let's substitute in the first equation. So 3 times minus 1 over 2 plus 5y is equal to 6. So minus 3 over 2 plus 5y is equal to 6. 5y is equal to 15 over 2, which means y is 15 over 2 divided by 5. That's 3 over 2. So I've got minus 1 over 2 for the x, 3 over 2 for the y. In question 8, I've got a decrease of 19% per year. This means that I have a multiplying factor of 81 over 100, which is 0.81. The 81 comes from 100 minus 19. So 20,000 times 0.81 to the power of 3 gives me 10,628.82, which is 10,629 to the nearest integer. For question 9, the area in contact with the table is the following. This is a rectangle with length 1.2 and width x, so it has an area of 1.2x. Now, using the formula given, pressure is equal to force over area. I've got 30 equals to 27 over 1.2x. Let's cross multiply. 36x equals to 27. So x is 27 over 36. This is the same as 0.75. In question 10, part A, I need to subtract the area of the Atlantic minus the area of the Indian Ocean. So we've got 1.06 times 10 to the power of 8 minus 6.86 times 10 to the power of 7. Now, although you can put this on the calculator and get the answer, if you want to do this manually, you're going to say 1.06 times 10 to the 8 minus, convert this to a power of 8, it becomes 0.686. Doing this subtraction will give you 0.374 times 10 to the power of 8. And if you convert this into standard form, you will get 3.74 times 10 to the power of 7. For part B, I've got Pacific is equal to K times the Arctic. So K is equal to the area of the Pacific over the area of the Arctic. So 1.56 times 10 to the 8 divided by 1.41 times 10 to the 7. This is 11.06 and so on. So K is equal to 11 to the nearest whole number. For part A of question 11, the integers that satisfy this inequality are minus 1, 0, 1, 2, 3, and 4. Now for part B, I need the three inequalities that define this region. Now note, let's start with y is equal to x. I need the region below this line, so y is less than or equal to 6. Let's take this line here. I need the region that is above this line, so I've got y is bigger than or equal to x minus 3. And finally, let's take this line here. I need the region above this line. I will rearrange this as y is equal to 5 minus x. So the region above this line is y is bigger than or equal to 5 minus x. And note that any rearrangement of this formulae is still correct. For example, for the last one, you could have y plus x is bigger than or equal to 5. I'll start question 12 by finding the angle ABC. ABC is the angle here. This one is equal to 180 minus 66 and 66. Since I have a triangle, this one comes out to be 48. Now I will label the interior angle of polygon X and polygon Y by X. Now to find this interior angle, I will do the following: 360 minus 48 divided by 2. It comes out to be 156. And then to find the number of sides, you can either work with this interior angle or find the exterior angle, which is 180 minus 156, and work out with the exterior angle. I will proceed with method 1 using the interior angle. So interior angle is equal to 180 n minus 2 over n. In my case, 156 is equal to 180 n minus 2 over n. Let's cross multiply. 156n equals, and let's expand, 180n minus 360. So 360 is equal to 24n, and comes out to be 15. In question 13, I've got a prism where the cross section is a trapezium, and I'm given the volume of the prism. I'll start by finding the cross-sectional area in terms of h. So here is the cross-section again. So the area of the trapezium is given by the following formula: base 1 plus base 2 times height over 2. In our case, I've got 12 plus 7 times h over 2. If I simplify this one, I will get 19h over 2. Now the volume of a prism is equal to the cross-sectional area times the length. So 608 is equal to 19h over 2 times 10. 608 is equal to 95h, which means that h is 32 over 5, or 6.4 if you want the answer as a decimal. For question 14, I'll start by putting these numbers in ascending order. Now you can either do this by inspection or using the formula for the lower and upper quartiles. If you're going with inspection, note that the middle value is 14, and the middle value of the left part, these numbers here, is 11. So that would mean Q1 is 11, and the middle number of the other set of values is 17. That would be Q3. Now, if you want to use formulae for this, Q3 is found by first calculating 3/4 of n, in our case 3/4 of 11. This is 8.25. So I'm going to take the 9th observation, and this is equal to 17. For Q1, I'm going to take 1/4 of my observations. This will give me 2.75, which means I'll take the third value, which is 11. Irrespective of the method you decide to find Q1 and Q3, you'll need to calculate the quartile range, which is given by Q3 minus Q1, so 17 minus 11. This will give me 6, which is the final value for the interquartile range. For part A of question 15, I'll put the x values on the calculator and calculate the missing y values. These come out to be 2 minus 1.5 minus 3 and 0. Now for part B, let's plot these points on the grid. And finally, join the points with a smooth curve to complete the question. Note that the minimum point is not on the y-axis, it's slightly to the right. To verify this one, you can use the equation of the line of symmetry, which is given by x equals minus b over 2a. In our case, a is 1, b is minus a half, and c is minus 3. So if I substitute these values, minus a half over 2 times 1, this will give me 1 over 4. That's the x-coordinate of the minimum point. So as you can see, this is somewhere here. For question 16, let's complete the tree diagram. So probability of getting an even number for bag A is 3 out of 10. And then for bag B, I've got 7 out of 12 odd, 5 out of 12 even, and the same numbers below. So this is a completed tree diagram for part A. Let's go to part B. I want the probability that I get a total to be an odd number. Now note, when I have two numbers, adding them and the sum is an odd number, it means that it's either odd plus even or even followed by an odd number. So if I get the probabilities from the tree diagram, I will get 7 out of 10 times 5 out of 12 plus 3 out of 10 times 7 out of 12. This will give me 56 out of 120, or 7 out of 15. For part C, the probability that Cody gets two even numbers is 3 out of 10 times 5 out of 12. And the probability that Harriet gets an even number is P, for example, any letter is valid. And this should be equal to 3 over 100. Now let's try and solve for P. 15 over 120 P is 3 out of 100. So P is 3 over 100 divided by 15 over 120. So this gives me 6 out of 25. Now this is the important stuff. I have to make sure that this is in its simplest form. You have to simplify this one. The calculator will do that for you. So once you find this answer in its simplest form, then the least number of counters that Harriet has is the denominator of this number. So the correct answer is 25 counters. For question 17, I'm given some information. I have to complete the Venn diagram. I'll start completing this one inside out. Now I have 5 with no dog, no cat, no rabbit. That's the outside. Let's put it to get it out of the way. So let's start from the inside. I've got 6 with all 3 animals. Now X have both a dog and a cat. So these 2 regions are X. So the top one is X minus 6. I've got 9 with a dog and a rabbit. So these 2 regions are 9. 9 minus 6 gives me 3 for both dog and rabbit without the cat. Similarly, 8 have both a cat and a rabbit, so these two regions are 8, which leaves 2 for this region. So let's go to the big circles now. 20 have a rabbit, so this region here would be 20 minus 6 plus 3 plus 2. This will give me a 9. 18 have a cat, so this region here is equal to 18 minus x minus 6 and 6 and 2. And if you simplify this one, you will get 16 minus x. And 28 have a dog, so similar to the cats, this one will be 28 minus x minus 6 plus 6 plus 3. This one simplifies to 25 minus x. For part B, I know that there's a total of 50 students, so if I add all the regions and equate to 50, I will create an equation. So the equation will be the following. If I simplify this one, I'll get 60 minus x equals to 50. So x is equal to 10. And finally, part C, I need the number of students with C dash intersection D dash. This means that students that do not have a cat and do not have a dog. So from my Venn diagram, this includes this 9 plus 5, 14 students. For question 18, I have two intersecting chords. The point of intersection is P. So the formula is the following: PA times PB equals to PC times PD. So let's substitute the values. 9 times 6 equals to 8 times PD, which means that PD is equal to 9 times 6 over 8. Putting this on the calculator will give you 6.75 centimeters. For part A of question 19, the three denominators are 5, 2, and 1. The lowest common multiple is 10, so I'll multiply the first one by 2, second one by 5, third one by 10. So I've got 2 times 4 minus 3x minus 5 times 3x minus 5 is equal to minus 30. Note, I am keeping the brackets. There's a minus times a minus to be created, so be careful. 8 minus 6x minus 15x plus 25 is equal to minus 30. Let's collect all x's on one side. So I've got 21x on the right. I'm taking all the x's to the right, so they're positive. I've got 63 on the left, so x comes out to be 3. For part B, I'll take everything to the left, so 5y squared minus 17y minus 40 is less than or equal to 0. Let's factorize 5y plus 8 and y minus 5 is less than or equal to 0. Now the critical values for these are y equals minus 8 over 5 or y is equal to 5. Let's make a small sketch. I'm only interested in the x-axis. Since I want the values less than or equal to 0 and the values below the axis, so that means I want all the values between the two critical values. So my final answer would be minus 8 over 5 less than or equal to y less than or equal to 5. For question 20, I've got two similar shapes. Now note, I've got the small one and I've got the large one. Now in terms of the length, 9 is multiplied by a scale factor of k and becomes 13. So 9k is equal to 13, which means k is equal to 13 over 9. So in terms of the area of the small one, that's a, gets multiplied by k squared to give me the area of the large one. So I get 13 over 9 squared times a. This simplifies to 169 over 81a. That's the area of the second vase. So if I add the two areas, a plus 169 over 81a, I should get 1800, which is given in the question. So 250 over 81a on the left equals 1800. So the value of a is given by 1800 divided by 250 over 81. The calculator will do that, and the answer is 583.2 centimeters squared. For part A, I'll factorize both numerator and denominator. This will give me 5x plus 4 multiplied by 2x plus 3 over, and in the denominator I have the difference of two squares, and I get 2x minus 3, 2x plus 3. So I can cross out the 2x plus 3 from top and bottom, and I'll be left with 5x plus 4 over 2x minus 3. For part B, I'll first convert everything as a power of 2. So this one, the top one, on the right hand side, 8 to the power of 5y becomes 2 to the power of 3 to the power of 5y, which is 2 to the power of 15y. And then for the denominator, 4 to the power of n, I get 2 squared to the power of n, so 2 to the power of 2n. And if I put everything together, I'll get 2 to the power of 2y times 2 to the power of 3y plus 2 is equal to 2 to the power of 15y over 2 to the power of 2n. On the left, I will add these powers. On the right, I will subtract the powers, so I get 2 to the 5y plus 2, and on the right, I get 2 to the power of 15y minus 2n. Now that I have one expression on the left, one on the right, I can equate the powers. So 5y plus 2 is equal to 15y minus 2n. So 2n is equal to 10y minus 2. And if you divide everything by 2, you get n equals 5y minus 1, which is the answer I want. For question 22, let's first recall the two formulae we know about sequences. The nth term is given by a plus n minus 1d, and the sum of n terms is given by n over 2 times 2a plus n minus 1d. A is the first term, in this case minus 6, and d is the common difference, which we don't know and we're going to find out. So let's start by what we are given, that the sum of the first 30 terms is 2865. So sum equals 30 over 2 times minus 6 plus 30 minus 1 d. Let's simplify. Now for the sum, I've got 2865 equals to 15 minus 12 plus 29d. I'll divide both sides by 15, so 191 is equal to minus 12 plus 29d. 203 is equal to 29d. d comes out to be 7. So using the nth term formula, I've got that the 9th term is equal to a, which is minus 6, plus n minus 1 times the common difference, and this will come out to be 50, which is the final answer. For question 23, recall that the formula for completing this square is the following. Now, before I can complete the square with the given expression, I'll need to set it up. So I've got an x squared plus or minus an x. So 7 minus, I'll take out a common factor of 2. And then I have x squared plus 6x. So now for this expression in blue, I'll apply the formula. So x squared plus 6x equals to x plus half of 6 is 3 squared minus 3 squared. Let's simplify this. X plus 3 squared minus 9. So let's go back to the original expression. 7 minus 2. I'm going to keep the square bracket. X plus 3 squared minus 9 is what I got on the side. So let's expand now the squared brackets only. 7 minus 2x plus 3 squared. And now be careful, that's where it usually goes wrong. Minus 2 needs to be multiplied by minus 9 as well. So I get plus 18. And when I simplify this, I'm going to get 25 minus 2x plus 3 squared. And this is my final answer. For question 24, let's start by writing down what we have. So line 1 has an equation of 5x plus 10y is equal to 8. Let's try and rearrange this to get y on its own. So 10y is equal to minus 5x plus 8. Let's divide this by 10. And let's split to get the gradient in the y-intercept. So minus 1 over 2x plus 4 over 5. So the gradient of line 1 is minus 1 over 2. Now line L2 is perpendicular to line L1. This means that the gradient of line 2 is minus 1 over the gradient of line 1. So if you divide minus 1 divided by minus a half, you'll get 2. I know that this line passes through the point 8, 6. So let's find the equation y equals mx plus c. 6 equals to 2 times 8 plus c. C comes out to be minus 10. So the equation is y is equal to 2x minus 10. Now the line L2 crosses the x-axis at the point A. So when y is equal to 0, I've got 2x minus 10 is equal to 0. X comes out to be 5. So A is the 0.50. Now I'm also given that L2 intersects the straight line with the equation x equals to minus 3 at point B. So when x is equal to minus 3, y comes out to be 2 times minus 3 minus 10 is equal to minus 16. So B has coordinates minus 3 minus 16. I need to find the area of the triangle AOB. So let's draw a sketch putting these points and joining them to get the triangle. So this is a triangle I have. Its base is equal to 5 and its height is equal to 16. So the area is given by base times height over 2, which comes out to be 40. For question 25, I'm given that n is a multiple of 5. This means that n can be written as 5 times a constant, where a constant is a positive integer. Now a is n plus 1, b is n minus 1, so a squared minus b squared is equal to n plus 1 squared minus n minus 1 squared. Let's replace n with 5k. So we've got 5k plus 1 squared minus 5k minus 1 squared. Let's expand now. 25k squared plus 10k plus 1 minus 25k squared minus 10k plus 1. I'll remove the bracket. So 25k squared plus 10k plus 1 minus 25k squared. Now be careful, minus times a minus gives plus 10k minus 1. I can cancel out the 25k squared and also the plus 1 with the minus 1, and I am left with 20k, which means it's a multiple of 20. So I'm just going to write proved, and that's the end of the question. For question 26, I'll join A and B. The point of intersection of the two diagonals is N. Now assume that ON is a fraction lambda of the line OC, and the line ON is a fraction mu of the line AB. Now the strategy here is to find ON using two different roots and equate those two roots. So I'll start by finding ON directly from O to N. First I'm going to need OC. So OC is equal to 3A plus 4B. Then ON is equal lambda times OC, which means ON is equal to lambda times 3A plus 4B. I can expand this and get ON is 3 lambda A plus 4 lambda B. The second route I'll follow is from A to N through A. First, I'm going to need A and B. And this is equal to minus 3A plus 6B. Then ON is equal to OA plus mu times A and B. So ON is equal to 3A plus mu times minus 3A plus 6B. If I expand the bracket, I'll get 3A minus 3 mu A plus 6 mu B. And if I collect the coefficients of A, basically if I factorize out A, I'll get A 3 minus 3 mu plus 6 mu B. The next step is to equate the A's on the left with the A's on the right and the B's on the left with the B's on the right. So I've got 3 lambda A's on the left. I've got 3 minus 3 mu A's on the right. So I have 3 lambda equals 3 minus 3 mu. I can divide this by 3 to get lambda equals to 1 minus mu. Similarly for the B's, I've got 4 lambda on the left, I've got 6 mu on the right, so 4 lambda equals to 6 mu, and I can divide this by 2 to get 2 lambda equals to 3 mu. and now I'm going to solve simultaneously. I'll substitute 1 minus mu in the place of lambda, so I get 2, 1 minus mu equals 3 mu, so 2 minus 2 mu equals 3 mu, 2 equals 5 mu, so mu comes out to be 2 over 5. I can find lambda if I want, given any of those two relationships. Lambda comes out to be 3 over 5. And now I can substitute either the lambda on the left expression or the mu on the right one. Let's substitute lambda on the left expression, so I get On equals 3 times 3/5 A plus 4 times 3/5 B, and if I simplify this one, I'll get 9 over 5 A plus 12 over 5 B.